Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Mo's Intensive Math class. Today we're going to be talking about a very important subject, LCM and LCD. The LCD and the LCM are pretty much the same thing. We're going to talk about that in a second. However, in order for you to be able to add or subtract fractions or mixed numbers, you have to be able to find an LCD and convert the fractions into equivalent fractions with the same LCD. Without that, you cannot add or subtract fractions unless they have the same denominator. So LCM stands for least common multiple. LCD is the same exact thing except it's the least common denominator. Okay? So when you're looking for the LCD, you're looking at the denominators and you're finding the least common multiple of the denominator. That's why it's called the least common denominator. Now, if you remember, guys, multiples are the product of one whole times every other whole number. Multiples are always greater than or equal to the original number. And every number has an infinite number of multiples. For example, let's list the first 10 multiples of 5. How do we do that? Well, we take the number in question, which is 5, and we literally multiply it by every single whole number starting with 1. So 5 times 1 is 5. That's the first multiple of 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. 5 times 6 is 30. 5 times 7 is 35. 5 times 8 is 40. 5 times 9 is 45. 5 times 10 is 50. ... Those 3 dots mean that this can go on literally forever. So multiples are always greater than or equal to the original number. Unlike factors, we use factors to reduce fractions. Factors are less than or equal to the original number. Okay? But multiples, you start with the original number they give you, and you multiply by every single whole number starting with 1. Now, we learned about prime factorization to find the GCF. Prime factorization is also very useful for finding the LCM of 2 or more numbers. Now, the best thing to be able to do, okay, is to know your multiplication tables backwards and forwards, and you don't have to do an LCM by prime factorization. If you know your times tables backwards and forwards, you can find the LCD or the LCM in seconds. However, let's say you don't. In a pinch, we can do the prime factorization. So let's break this down. 18 breaks down into 2 times 9, circle the prime. 3 times 3, circle the prime. 20 is 2 times 10, circle the prime. 10 breaks down to 2 times 5, circle the prime. Now we've seen this LCM skill before. I'm going to refresh your memory. Please remember that the LCM equals the GCF times the left over primes. Literally. So let's first find the GCF to this. Remember that the GCF, every pair comes out as one value. So I have a 2 and a 2, so it comes out as a 2. Do I have 2 3s on both sides? Do I have another 2 2s on both sides? Do I have another 2 5s on both sides? So what's my GCF? 2. And what is the LCM? The LCM is the GCF, which is 2, times the leftover primes. What are the leftover primes here? A 3 times another 3 times a 2 times a 5. So 2 times 5 is 10. 10 times 9 is 90 times 2 equals 180. And that is the LCM. Again, if you know your times tables, you could have easily answered that quickly, very quickly. If you don't know your times tables, no big deal. You can use prime factorization to find your LCM or LCD. Now, how does this work as far as finding an LCD? Okay? When we're finding an LCD, we're focusing on the denominators. Okay? I don't want to do prime factorization. I want you guys to know this quicker than that. Can anyone tell me, using their multiplication skills, what is the least common multiple of 12 and 8? Yes, sir. Okay, hold on. Whoever said 2 and 4, didn't we already say that the least common multiple is always greater than or equal to the original number? So, for those of you that said 2 and 4, 2 and 4 are factors of 12 and 8. What is the least common multiple? Multiples are going to be larger than the 12 and 8. What are the least common multiple of 12 and 8? Yes, sir. 24 is exactly correct. The LCD here would be 24. Now, let's say you're thinking to yourself, but I don't want to do prime factorization. Okay, do it another way. What are the multiples of 12? 12, 24, 36, 48. What are the multiples of 8? 8, 16, 24. Hold on. Check it out. Isn't that the first common multiple? That means that's the least common multiple. Guys, please though, do not confuse multiples with factors. If I wanted to reduce, let's say I want to reduce, I don't know, 8 twelfths. Now here we divide by the common factor. What's the GCF, the greatest common factor of 8 and 12? What number goes into both 8 and 12? What's the largest number that goes into 8 and 12? 4. So you divide 4 to both top and bottom, and that would be 2/3. Here, you divide it by the GCF. You divide it to get that to a simplified fraction. This here is different. When you're finding the LCD, you're looking for common multiples. Are you with me here, guys? You promise. Now, if I know that the least common denominator here is 24, let's say that I wanted to add these two fractions. I would have to convert each of the fractions, both 5/12 and 1/8, into a fraction that had the common denominator of 24. So I have 5/12 here, and I have 1/8. If I wanted to add these, which is coming up very soon, okay, I've got to convert this to something over 24, and I got to convert this into something over 24. What do I multiply to 12 to get to 24? What times 12 is 24, guys? 2. So whatever I multiply to the denominator, I must multiply to the numerator. So what will my numerator here be? 10. What times 8 gives me 24? 3. Whatever I multiply to the denominator, I must multiply to the numerator. And I would have here in the numerator 3. So once you find the LCD, okay, You must convert the given fractions, and then I can start adding. And we'll get into adding later, but this is the precursor to adding. If you don't know how to do this, you will not be able to add fractions. Is everyone with me so far, gentlemen? Okay. Now, I already went ahead a little bit. In order to add or subtract fractions and mixed numbers, you will have to find the LCD. Then convert both fractions or mixed numbers into fractions with like denominators. This is done by simply multiplying both the numerator and denominator by the same value that will give you the desired LCD. So let's practice. Find the LCD for each of the following fractions, then find the equivalent fractions using the LCD. What is the least common denominator here of 3 and 2? 6, guys. When in doubt, you can just multiply them together. What are the multiples of 3, guys? 3, 6, 9. What are the multiples of 2, guys? 2, 4, 6. Which is the least common denominator here? 6. Okay, now, that 1/3, I've got to convert it into something over 6. And that 1/2, I have to convert it into, actually, let me go ahead and make this a little easier for us, into something over 6. What did I multiply to the denominator of 3 to get to 6? 2. What do I have to multiply to the numerator? So that becomes 2/6. What did I multiply to the denominator of 2 to get to 6? And what do I have to then multiply to the numerator? So I get, hello? 3/6. Yes, sir. If you reduce them, then they go back to the original, and then you cannot add them. So no. If you have to follow the directions, my man, find the LCD, and then convert the fractions into equivalent fractions using the LCD. Guys, just so you understand, now that you have 2/6 and 3/6, if I wanted to add these, what's 2/6 plus 3/6? 5/6. That's why we need this skill. You cannot add 1/3 and 1/2. They're different sizes. They're different slices. So you have to know how to do this in order to add and subtract fractions and mixed numbers. Okay, what's the LCD of 2/5 and 3/4? 20. Very good. Okay, now let's convert 2/5 into something over 20, and let's convert 3/4 into something over 20. What did I multiply to the denominator of 5 to get to 20? 4. What do I have to multiply to the numerator? So what is my numerator then? 8/20. See how easy this is, guys? But you got to actually follow directions. What did I multiply to the 4 to get to 20? 5. Very good. So what do I have to multiply to the numerator? 5. Okay, what's my numerator then of the new equivalent fraction? 15. Bam. Done. Questions, comments, concerns, problems, issues? I am here for you guys. Talk to me, please. Okay. And we shall continue. Okay, what is the LCD of 8 and 5? 40. Very good. So I'm going to convert 1/8 into something over 40. And I'm going to convert 3/5 into something over 40. What did I multiply to the 8 to get to 40? So what do I have to multiply to the numerator? Very good. So what's my new fraction going to be? 5/40. Very good. And then what did I multiply to the 5 to get to 40? And what do I have to multiply to the numerator then? So my new equivalent fraction is 24 40ths. Very good. For D, what is the LCD of 7 and 9? 63. Excellent, gentlemen. So I got to convert 5/7 into something over 63, and I got to convert 4/9 into something over 63. What did I multiply to 7 to get to 63? 9. So what must I multiply to the numerator? So my new fraction will be 45/63. Excellent. What did I multiply to the 9 to get to 63? 7. What do I have to multiply to the numerator then? So what will my new fraction be? 28/63. Is this making sense, gentlemen? You promise? Questions, comments, concerns, problems, issues? You with me here, boys? All right, awesome. So, for the first set here, let's just find the LCM, the least common multiple. Let's see if our multiplication skills are strong. What's the least common multiple of 2 and 3? 6, good. What's the least common multiple of 3 and 4? 12, excellent. What's the least common multiple of 2, 3, and 5? 30, very good, very impressed. What's the least common multiple of, no, of 3 and 12? It's not 36, it's 12. Think about it, guys. What are the multiples of 12? 12, 24, 36, 48, dot, dot, dot. What are the multiples of 3? 3, 6, 9, 12, stop. 12 and 12. The least common multiple is the smallest or first common multiple. Does that make sense, gentlemen? Okay. What's the least common multiple of, okay, some people are saying 48, but that's wrong. It's 24. Now, is 48 a common multiple? Yes, it is. Is it the least common multiple? No. What is the least common multiple of 8 and 12? Also 24. Very good. Beautiful. Does that make sense, gentlemen? Okay. Let us continue. Last but definitely not least. Find the LCD for each of the following fractions, then find the equivalent fractions using the LCD. So what is the least common denominator here? 35. So I've got to convert 2/7 into something over 35 and 1/5 into something over 35. So what did I multiply to the 7 to get to 35? 5, so I must multiply 5 to the numerator as well. Good. So what is my new equivalent fraction? 10/35. Good. What did I multiply to 5 to get to 35? 7. So what must I multiply to the numerator? 7. So what is my new equivalent fraction? 7/35. Excellent. Does that make sense, gentlemen? Now from here we can add, okay? That's what we're going to do in our next lesson. Okay, what is the LCD here between 5 and 3? 15. Beautiful. So I've got to convert 2/5 into something over 15. Whoa, come on now. Something over 15. And I've got to convert 2/3 into something over 15. So what did I multiply to 5 to get to 15? So what must I multiply also to the numerator? 3. So that's going to be, my new equivalent fraction is 6/15. Very good. Now, If anyone's asking, why are you multiplying by 3 over 3? What is 3 divided by 3 equal? 1. So am I changing the value of 2/5 or just the appearance? What's 1 times any number, guys? Itself, right? So if I multiply 1 by 2/5, am I not getting 2/5 again? Okay. So what is the value of 3 over 3? 1. So am I changing the value of 2/5 or the appearance of 2/5? The appearance. 2/5 and 6/15 are the same exact thing. Whenever you multiply or divide the same number to the numerator and denominator, you are simply changing the appearance, not the value. And I'll prove it to you. 4/8, if I divide that by 4 over 4, I get 1/2, right? Guys, isn't 4/8 the same as 1/2? I divided by the same number to numerator and denominator. If I take 1/2 and I multiply by 4 over 4, doesn't that give me 4/8? So whenever I multiply or divide the same number to both the numerator and denominator, I am creating equivalent fractions. Does that help make sense of things? Questions on this, guys? This is really important. Okay. So, back here, what did I multiply to 3 to get to 15? So what must I multiply to the numerator? So I get my new fraction of 10/15. Okay. What is the LCD of 2, 4, and 3? 12. Very good. So I got to convert 1/2 into something over 12, 1/4 into something over 12, and 1/3 into something over 12. What did I multiply to 2 to get to 12? 6. So I must multiply 6 to the numerator, giving me the fraction, the equivalent fraction, 6/12. What did I multiply to 4 to get to 12? 3. So I must multiply 3 to the numerator, giving me the equivalent fraction of 3/12. What did I multiply to 3 to get to 12? 4, which I must multiply to the numerator, giving me the equivalent fraction of 4/12. Does that make sense, gentlemen? Okay, what is the LCD of 5 and 6? 30. Okay, not 30 over 12. That's a fraction. Okay. Okay, no. No. No, it's not, Papa. And the answer of C is not 30 over 12 either. If I wanted to add all of the... Hold on, man. Relax. If I wanted to add 6/12 plus 3/12 plus 4/12, yes, that would be 13 over 12. But that's not what I'm asking. I'm asking for the LCD of D, the LCD of 5 and 6, which is 30. Now, I've got to convert 2/5 into something over 30 and 1/6 into something over 30. What did I multiply to 5 to get to 30? 6. So I must multiply 6 to the numerator as well, giving me the equivalent fraction 12/30. Very good. What did I multiply to 6 to get to 30? 5. So I must multiply 5 to the numerator, giving me the equivalent fraction of 5/30. Does that make sense, gentlemen? Questions on this, gentlemen? Fantastic. I hope you learned a lot. Thank you very much and have a wonderful day.